Examining electrical configurations as they originate from the factory provides insight into the intended operation and expected lifespan of electrical devices. The initial design considers various factors, including voltage requirements, current draw, and safety standards. Understanding these factory settings is crucial for maintaining the device's optimal performance and preventing potential hazards over an extended period. For example, an appliance designed to operate at 120 volts should consistently receive that voltage level. Fluctuations outside the specified range can lead to reduced efficiency, overheating, or even permanent damage. Similarly, the factory-installed wiring and circuit protection are sized to handle the anticipated current load. Modifying these components without proper knowledge can overload the system and create a fire risk. Over time, components can degrade due to environmental factors such as heat, humidity, and dust. Regular inspection and maintenance are essential to identify and address any signs of wear or corrosion. This includes checking the condition of wiring, connectors, and insulation. If any damage is detected, it should be promptly repaired or replaced by a qualified electrician. Furthermore, it's important to be aware of any updates or recalls issued by the manufacturer. These advisories often address potential safety concerns or performance issues that may arise after prolonged use. Following the manufacturer's recommendations for maintenance and repairs can significantly extend the life of the appliance and ensure its safe operation. The factory configuration also dictates the grounding system. A properly grounded device provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. It is crucial to verify that the grounding system is intact and functioning correctly. This can be done using a multimeter to measure the resistance between the appliance's metal chassis and the grounding electrode. A low resistance reading indicates a good ground connection. In addition to voltage, current, and grounding, the factory configuration may also include specific control circuits or safety interlocks. These features are designed to protect the user and prevent damage to the appliance in the event of a malfunction. Tampering with these circuits can compromise safety and void the warranty. When troubleshooting electrical problems, it's always best to start by referring to the factory wiring diagram. This diagram provides a detailed map of the electrical connections and components within the device. By tracing the circuit, you can identify potential points of failure and narrow down the source of the problem. If you're not comfortable working with electricity, it's always recommended to seek the assistance of a qualified electrician. They have the knowledge and experience to diagnose and repair electrical problems safely and effectively. Firstly, identify the specific model number of the appliance. Secondly, locate the manufacturer's documentation, which may include a wiring diagram and troubleshooting guide. Thirdly, inspect the power cord and plug for any signs of damage. Fourthly, check the circuit breaker or fuse that supplies power to the appliance. Fifthly, use a multimeter to measure the voltage at the outlet. Sixthly, if the voltage is correct, check the continuity of the wiring within the appliance. Seventhly, if the wiring is intact, test the individual components such as switches, motors, and heating elements. Eighthly, replace any faulty components with original equipment manufacturer or OEM parts. Ninthly, reassemble the appliance and test it to ensure that it is functioning properly. Tenthly, if the problem persists, consult a qualified electrician. Maintaining the factory electrical configuration is not just about preserving the appliance's functionality, it's also about ensuring safety. Any unauthorized modifications or repairs can create a hazardous situation, potentially leading to electrical shock, fire, or even death. Always prioritize safety when working with electricity and follow all applicable codes and regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations and safety practices. Understanding and adhering to these guidelines is essential for preventing electrical accidents. When dealing with older appliances, it's important to consider the age of the wiring and components. Over time, insulation can become brittle and crack, increasing the risk of short circuits. It may be necessary to replace the wiring or upgrade the entire appliance to meet current safety standards. Furthermore, be aware of the potential for asbestos in older appliances. Asbestos was commonly used as insulation in electrical equipment prior to the 1980s. If you suspect that an appliance contains asbestos, do not attempt to remove it yourself. Contact a qualified asbestos abatement professional to handle the removal safely. When purchasing new appliances, look for models that are energy efficient and environmentally friendly. Energy-efficient appliances consume less electricity, reducing your energy bills and minimizing your carbon footprint. Environmentally friendly appliances are made from sustainable materials and are designed to be recycled at the end of their lifespan. By making informed choices about the appliances you use, you can contribute to a more sustainable future. In conclusion, understanding the factory electrical configuration of your appliances is crucial for maintaining their performance, safety, and longevity. Regular inspection, maintenance, and adherence to safety guidelines are essential for preventing electrical accidents and ensuring the safe operation of your electrical equipment. Remember to always prioritize safety when working with electricity and seek the assistance of a qualified electrician if you are not comfortable performing the work yourself. The electrical system is designed with specific wire gauges based on the amperage requirements of the load. Altering wire gauges can lead to overheating and potential fires. Circuit breakers are also selected based on the wire gauge and load. A breaker that is too large will not trip in the event of an overload, while a breaker that is too small will trip unnecessarily. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by detecting imbalances in the current flow. They are commonly used in bathrooms, kitchens, and other wet locations. Arc fault circuit interrupters, or RFCIs, are designed to protect against fires caused by arcing faults. They are typically installed in bedrooms and other areas where flammable materials are present. Surge protectors are designed to protect electronic equipment from voltage spikes. They are commonly used to protect computers, televisions, and other sensitive devices. Uninterruptible power supplies, or UPSs, provide backup power in the event of a power outage. They are commonly used to protect critical equipment, such as servers and medical devices. Electrical panels should be properly labeled to identify the circuits they control. This makes it easier to troubleshoot electrical problems and perform maintenance. Electrical outlets should be properly grounded to prevent electrical shock. 3-prong outlets are grounded, while 2-prong outlets are not. Extension cords should be used sparingly and should not be overloaded. Overloading extension cords can cause them to overheat and create a fire hazard. Light fixtures should be properly installed and maintained. Loose connections can cause arcing and create a fire hazard. Electrical work should always be performed by a qualified electrician. This ensures that the work is done safely and in accordance with all applicable codes and regulations. NEC Table 310.15b16 outlines the ampacity of conductors based on their size and insulation type. It is important to consult this table when selecting the appropriate wire gauge for a given application. The voltage drop in a circuit should be limited to a maximum of 3%. Excessive voltage drop can cause appliances to malfunction and reduce their lifespan. Electrical equipment should be protected from moisture and corrosion. Moisture can cause electrical shorts and corrosion can weaken electrical connections. Electrical boxes should be properly sized to accommodate the wiring and devices they contain. Overcrowded electrical boxes can create a fire hazard. Electrical tape should be used to insulate electrical connections. Electrical tape should be rated for the voltage and temperature of the application. Wire connectors should be used to connect wires together. Wire connectors should be rated for the wire gauge and type of wire being connected. Electrical conduit should be used to protect wiring from physical damage. Electrical conduit should be made of metal or plastic. Grounding electrodes should be properly installed to provide a path for fault current to flow back to the source. Grounding electrodes should be made of copper or galvanized steel. Bonding jumpers should be used to connect metal enclosures to the grounding system. Bonding jumpers should be made of copper or aluminum. The electrical system should be inspected regularly for any signs of damage or wear. Any problems should be repaired promptly by a qualified electrician. When working with electricity, always wear appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Always disconnect the power before working on any electrical equipment. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, seek the assistance of a qualified electrician.